Hello and welcome to another Great Cow Basic tutorial for the 16F171 chip family. Hello, my name is Venn. I'm a co-developer of Great Cow Basic, the compiler and toolchain, along with a whole load of other people. So if you like this video, please press the like key, the thumbs up, and leave comments. So let's get into the session itself. This is around bringing together all the pieces that we've done to date in the previous videos. So we're going to use the LEDs, the switch, the ADC, we're going to flash them, and then we're going to rotate them. And then we're going to sort of push that aside in the next few videos and talk about other capabilities of this chip and this chip family. So what am I using? I'm using a microchip low pin count demo board. You can also make your own on a piece of breadboard, and Chris Roper's put together a diagram for you. You can see that in the previous videos and in the PowerPoint that I should be publishing. I received this in the post, which is quite interesting. It's a clone. It's a clone of this board. So people are cloning these things. Let me just show you that in the lab look. Here is one that's been sent to me. It looks, I'll turn it around, looks pretty similar. But someone's made that, and you can tell they've done it quite well because there's a resistor hanging off the bottom. But people do make these things, which is quite interesting. So I'm using the low pin count demo board because it's very, very useful for what we're doing. This is the layout. I'll leave that there for 4 seconds and then move on. So, as I said, we're pulling this all together. So we're going to have the LEDs rotating in sequence. We're going to use the switch to control the direction of the sequence, and that will become apparent. It will go to the left and then to the right, which is quite nice. We're going to use the master clear as an input, not as a reset. We saw that in the previous tutorial. We're going to use the ADC to read the voltage from the potentiometer, and we're going to use time to give us a consistent flash. So it is actually quite a useful demonstration. So how's it going to do this in terms of flow? So what we're going to do, we're going to initialize the board. Most of that's done automatically for you. We're going to have a do forever loop. We're going to read the ADC. I'm going to use an 8-bit read. Okay, this is a 12-bit read capable chip. I'm going to use an 8 for a particular reason, and it will become apparent. It's going to determine the state of the switch. Going to change the states of the LED and wait. And there's a flow diagram that says that read the ADC, has the switch state changed, then make them flash left or right, then do a wait, and then go back and do it again. And it's a very simple program and quite easily implemented. So what we're going to do is look at the sample code. We're going to review those results, and then we're going to change the microcontroller, which is quite important. I'm just going to show you that this is portable code, and then I'm going to revert the code. And that's quite important as well because these are demonstrations, so I need to publish them. So with that, let's get started. But I just need to tell you one thing. I've been using GCStudio. GCStudio is a managed environment. We provide a managed environment for the compiler and the complete toolchain. So it's consistent. It's a SourceForge distribution, and it's quite a lot of tools. So we've given you the option to get automatic updates, or you can turn those updates off if you want to have a static build or you're offline or something. But it's very useful to keep the tool chain up to date. So it auto updates, but you can turn it off. Okay, and you have to look in GC code to figure that piece out. But what does it look like is what I'm going to show you, because this happened to me this morning, which is good. I'm up to date now. So what happens is you'll get a menu like this. It will pop up, not a menu, but a display will pop up, and it will say download in the update 10%. And then it will progress through 18%, and it will progress through to 100%. And then eventually it sits there, and it will then finish the update. And what it's doing at this point, it's pulling down all the changes that are required to give you a consistent system. And that means that it should work every time. I've already done that on mine. It did it this morning, hence I'm showing you this. So let's go out to my desktop and get started. Press Windows, GCStudio, GCS on mine, pulls it up and open it up. I've got the banner here, the front page. I'm just going to zoom in for you. And then I'm going to click on the chip range recent usage and then open up the editor. And that's where we left it. This is where we left it. I'm just going to close the program down for you so that we end up with a clear screen. Let me zoom in. Control plus. Great. Remember, I'm going to put a filter on the files by pressing on the left-hand window, Control F, .gcb, and applying the filter. Done. And you can see we have a list. So if I open up the demonstration, I'm looking for 090 reversible LEDs. Let's just pull it what we did yesterday as well. 80, 90, 70. I've now got 3 loaded in the editor, and I'm going to close down the Explorer. And if you had more than 3 loaded, I want to point this out to you, so why I've loaded up more than one. You can rotate the top banner to see more files. So if I come in here, load some more up, close that. You can hover over the tabs, then using your mouse, you can rotate and choose which one you're going to be working on. And so you can load up many of these files. So I'm just going to close everything else except the one I want. 090 reversible LEDs with variable delay. That's what we're doing. So let's review the code. All the green stuff is comments, so I'm going to ignore that for today. Chip 16F126, option explicit. It's been consistent. This is consistent. We have defined a set of constants to refer to the LED port on LATC. We have some constants predefined for RC0 to RC3. They are the LED ports on the board, and I've set those to outputs. And the next 2 constants, potentiometer on port A0 and a switch in on port A3. And I create first of all, I create the constant, and then I set those 2 in, which is what I need to do. Then we're into our program. Our main program starts here. But what I'm going to do is I'm going to program it to start with, and then we're going to go walk the program after we've seen it work. So I'm going to select hex and flash, turn the camera on. Let me just go back to there. There we go. I was going to zoom in on the, there we go. I wanted to zoom in on it so we can see it. So what we've got is the LEDs rotating here in one direction on a specific delay. I'm now going to just speed that up so that you can see it in the video, getting slower and slower and slower. There we go, nice slow, that's the lowest speed. I'm going to press the reset button or press the input button and the direction changes. And again, I push the button and again, I push the button. So that's what we're doing. So we're using all 3 components. How are we doing that? We're doing that by setting some other constants in our main program. I've set up 2 constants called up and down, or down and up, and I've defined some bytes. We've seen how to construct bytes before. We need to define our variables. And then I've said LED right and LED left, and that is just a statement of directions. And the initial direction, so I'm setting the variable direction to LED right. And then there's I'll just move down to that sequence. There we go. If the LED direction is right, it essentially, uses rotate, which we've used before. It rotates the LEDs to the right, and if it overflows, then reset them back to the start. And that's I've taken you to that piece to start with, because it then sort of makes sense. If the direction is LED right, rotate them in one way, else rotate them in the other way. And here is the code for that, and the rotate left. So one is rotate right, and one is rotate left. And I was just setting the initial state. So if I minimize that and get it out of the way for the time being, you've seen this before, which is a macro that sets the initial state, so RC0 to 0, RC1 to 0, RC2 to 0, but it sets RC3 to 1. And then I set a mask up, and the mask is essentially going to ensure that the rest of port C is not affected. And there's an initial value of the LEDs. I'm going to, into the main program, I'm going to read the ADC, and I'm going to put it in a variable called delay. I scale that to a minimum of one unit to 200 units. And it's useful to do that, especially if you use a 12-bit delay, because 4-second delay on an LED would be quite a lot. So I'm just using the scale to give you the ability to review this and change the parameters if you want to use a 10-bit read or a 12-bit read. Then we, as before, we're in the code that says if the direction is LED right, then do something, else it must be left, do something different. Expand that code. And finally, it does the weight based upon the scaled value, and it says if the switch is true, therefore it is down. If the switch is true, then toggle the direction. So it says direction. Whatever the value of direction is, it's the not of that. So what was direction to start with? Direction was initially set to 0, and not 0 is 1. So it's essentially just going to toggle between these two, left and right, every time we press a button. The rest of the code is the debounce code we saw in the previous tutorial. It just works. It stops debouncing. So that is the code. All we've essentially got is if the direction is LED right, do rotate to the right. If it overflows, do something about it, reset, and if it's left, the same. So the code is quite simple, but it brings together all the pieces in the tutorial that we've done before. So what else I wanted to show you in here was code portability. So I've got a chip line here called hash chip, but I've got this one that came in the post. I don't even know what chip it is in there, to be quite frank, but I'm just going to plug it in, and it's working. So what I'm going to do, I'm going to go to my desktop. I'm going to start up my PIC16F171xx software. Zoom in for you so you can see it. And it tells me that it's a 16F171xx. I put that in my cut and paste buffer. Back into the code. All I'm going to do is change the chip here. And that's changed it. I'm going to press hex and flash, and we'll see what happens. There's no errors in the program. That means it's working, and it's now working in exactly correctly as expected. Click, click. Portable code. So the last part I wanted to show you was reverting the code. So I'm going to turn the camera off, and then we're going to look at another function within GC code. So I'm going to open up the Explorer, and if I look down in the list here, I can minimize my list of GCP files. I can look at the outline of this program, and these are all the variables and constants that have been defined and the functional areas. I can sort those. So it tells me that it's a 16F753. There's some constants being defined, some directions, and a function called check switch, and some ports. But the one I want to show you is timeline. So it says here I saved the file 1 minute ago, which I think I did. But if I click on it, it will tell me on the right hand side what I changed. Is there any changes in there? Oh, I haven't got enough history on this particular file yet. I haven't got enough history. But if you had a change in here, I'll make a change in here. I'll make a change in here. I'll put that back as it was. Save it. You can see now I'm getting a list of configuration changes. So I can now revert things. I can then say, what was it 1 minute ago? And it says you changed it between here and here. So I've got a history, a timeline that's running throughout my program. If I wanted to change the frequency to 4 megahertz, I save it, or remove option explicit might be a better option. I can then revert my code by pushing the arrow key here. It now puts the whole block back as it was. So you've got extensive change control within the GC code environment. And that's what I wanted to show you today. I'm just going to save my work. Save that. And if I now go back to my board, I can then reprogram the 17126. I'm just going to lean over and do that and put that back so I don't lose my track tomorrow. There we go. F5 just to confirm, or that's the same as saying hex and flash. And now it's operational. Great. Wonderful. Back to PowerPoint. So we used the switch ADC, made the LEDs flash in sequence, then they reversed around. Tomorrow, next tutorial, we're going to look at using the serial port or the UART on the microcontroller to talk to my computer to show the values that have been returned by the ADC. With that, we'll call it a wrap.